the NGOT project, which is a novel adaptive cybersecurity framework for the Internet of Vehicles. This project is part of the Horizon 2020 Research and Innovation Program and draws on the experience of the 13 partners coming from Europe and Israel, and it will be completed over the course of 36 months. Now we've already almost completed the first year. So what is the aim of the project? The aim is to deploy a novel, multi-layered, interoperable cybersecurity solution for the Internet of Vehicles, with an emphasis on connected and autonomous vehicles ecosystem, employing an advanced cybersecurity system that will enable all relevant stakeholders and incident response teams to share their cyber threat intelligence, to synchronize and coordinate their strategies, response, and recovery activities. The project develops a set of in-vehicle and V2X data collectors, which will feed into NGOT's machine learning platform, as well as tools for threat analysis and situational awareness across the IOV ecosystem. It involves advanced visual and data analytics, which are further enhanced to boost cyber threat detection performance under the scenarios of complex attacks. IOV stakeholders are jointly engaged in the incident response activities in the project through trusted mechanisms. And the proposed approach is supported by an interoperable data exchange between both existing and newly proposed cybersecurity tools. The goals then can be summarized into 5 major points. So first of all, to reduce the attack surface of the overall IOV ecosystem. Secondly, to showcase effective and real-time detection of novel advanced threats and cyber attacks in IOV ecosystems. Third, to reduce the response time and the impact of breaches. 4, to contribute to the establishment and sustainable operation of computer security incident response teams, stimulating information and knowledge sharing across the ecosystem. And finally, to pave the way for a new generation of robust, scalable, and resilient IOV infrastructure. So we're aiming to make a change in Europe in order to drastically reduce the number of fatalities, the harmful emissions from transport work, and also this could contribute to reducing congestion within urban environments. I know that some cities, for example, Amsterdam, are already working on car sharing initiatives that would assist in also helping the environment to be less damaged by emissions. So the aim, though, of this project is to detect cyber attacks in real time while at the same time preventing them. So detection and prevention. Possible attacks. There are many different kinds of attacks that a connected and autonomous vehicle could be subject to. Any networked computing device with a connection mechanism, in fact, has a vulnerability. But specifically in this scenario, we can think of attacks on authentication, routing attacks, data authenticity attacks, availability attacks, and secrecy attacks. The CAV and IOV environment bring with them inherently a number of ethical and legal challenges. So first of all, they can create new forms of cyber threats and risks. And there are new potential and unexplored attack surfaces. So we also need to think about potential new kinds of attacks. There is a need to understand the landscape in order to successfully develop these defense strategies, in fact. And of course, the subjects that we have to think of in this vulnerable CAV scenario would be passengers and pedestrians, as Francesco mentioned earlier. And so passenger security and privacy are fundamental to the success of the IOV development. Ethical concerns of CAVs are closely related to the legal principles that we have enshrined in the law, such as the General Data Protection Regulation. And for this reason, the CAV should be developed with ethics in mind, as the very notion of connected vehicles presents the developer with a number of ethical concerns and paradoxes which are inherent to the human-machine relationship. Concerns of safety could include accidents, property damage, of course, loss of life, as we're speaking about cars, environmental and workforce, as well as, for our purposes, privacy, data protection, and data security concerns. There are a few principles that we have identified that we believe are of fundamental importance in this area. The first is data protection by design and default. This principle is established in Article 25 of the General Data Protection Regulation and expects that data protection is taken into consideration from the very initial stages of any project that plans to process personal data. Data protection by design and default ensures that the good or service by default, as it says in the name, processes only the personal data which is necessary for the purpose. This also is connected to the principle of data minimization, which also extends to the configuration of software and information systems that are used to process personal data. So, from their very design phase, we minimize their use as well as the development of technologies or processes that aim to collect and process only the strictly necessary personal data to enable us to benefit from the required functionality. Closely related to the principle of data protection by design and by default is the concept of fairness by design. Fairness, in this case, relates to a balanced and proportionate data processing. So in this context, relevant stakeholders should take into account the interests and the expectations with respect to privacy of the data subjects. Who are the data subjects again? The passengers and the pedestrians. The processing of personal data in CAVs must not unreasonably intrude on the privacy, autonomy, or integrity of data subjects. And organizations should avoid putting any pressure on data subjects to provide their personal data, collecting only what is strictly necessary for the operation of the vehicle. Of course, this is even more complex if you think of a scenario such as a bus, so you have many passengers. Fairness in this way can go beyond what is strictly mandated by the law and take into consideration an ethical dimension which considers the data subjects. Fairness by design balances fundamental rights and freedoms, and like data protection by design, it should be built into the very design of connected vehicles. Their components and all of the data processing activities in connection to the CAF. Fairness should form an integral part of the algorithms that underpin the information and data processing, which should in themselves be developed in a way that is compatible with the concept of fairness by design. So fairness by design has two primary requirements. So first of all, we have to have a good approach to security. So based on an analysis of the risks associated to information, which should also be transposed into documented procedures aimed at identifying all threats that could pose risks to IT systems, as well as an assessment of the security measures in place to provide. Sorry,
Weź na ten teren. Ty najpierw idź słysz równolegle i niezależnie.
Ale on nam rzutuje na...
Excuse me, I think someone has their microphone on.
No, okay, it's muted.
And
we can continue.
Okay. And second of all, an ethics data protection impact assessment, which should be required to identify the high risks, the rights and freedoms of natural persons involved in the CAV. And of course, a set of appropriate solutions to mitigate such risks. Transparency is another important principle in any AI system or CAV environment. The rationale behind automated decisions can significantly affect individuals. We know this. Also, much work has been done surrounding an ethical and trustworthy AI, such as by the high-level group established by the European Commission. And it goes without saying that AI systems need to be able to be comprehensible to humans. We have to understand the decisions that are made and why they were made. And second, in order to be fully transparent, a sort of black box should record all of the decisions and logic that the transitions and logic that lead to specific decisions by the cab. So, for example, in this, you could even think of in the context of cab, where if the vehicle is about to have an accident, who should the vehicle run into? So should it kill the passengers, or should it kill the pedestrians, or should it kill a dog, a grandmother, a child? It's quite a complex and ethically challenging situation. And of course, we need to think about the legal basis. So since such a significant amount of data is involved in the data collection in the cab environment, which is further processed, we need to decide on an adequate legal basis. So within the system that is designed for the automated vehicle, consent could be chosen, for example. So for the collection of the passengers' data, and not that of the driver, who's the main data subject, whose personal data would be collected. Well, in this system, we must then ensure that consent has been incorporated into appropriate and valid way. This is actually quite challenging. So I hope that this has been of interest to you. These are some of our team members working on the presentation, on the project, and I will hand the floor back to my colleague, Francesco.
Okay, thank you very much, Kate. I'd like to leave the floor to Vito Pavese in order to conclude about NIOV. Thank you.
Yeah, thank you, Francesco. And yeah, just a quick comment about this project. Well, it's very novel, I would say, as also the acronym stands. And mostly it's focused on cybersecurity, as we have seen from the presentation made by Kate. But of course, we cannot leave data protection issues and challenges behind. We have experienced in recent years a lack of literature on this topic specifically. And we have seen, I would say, luckily enough, in recent months, in January, if I remember correctly, the first draft version of guidelines on processing personal data in the context of connected vehicles issued by the European Data Protection Board. Well, if you want to further deepen the topic, I suggest you to go through those guidelines. For most of it, we'll not say any new things about the IoT environment, and we can also relate to the 2014 guidelines issued by the Working Party, Article 29. On that topic, just a quick overview of the concepts that are highlighted in the guidelines, and that also we are strictly studying and following in the current project. Data controllers. Well, you see in the IoT context and the connected vehicles environment, there can be more than one data controller. It's also acting as joint controllers for some part, of the processing. There is a fascinating example of how we are already experiencing the Internet of Vehicles today. And if you see, if you look at, those black box connected installed in the vehicles, for example, the application on the smartphone that can track also movement and location while you're driving. If you are sharing driver also, well, you are participating in a collection of a very large amount of data every time you drive one of these cars. And well, cybersecurity threats are important to be highlighted, but also the adherence to the respect of the principles listed in Article 5 of the GDPR should be also a guidance. And for example, it's not enough to present information notice, more or less complete, or to try to see how to collect the consent of the data subject. Most of the times, the data controllers, when they install these applications on the vehicle, they rely on a contractual basis, not on consent, to collect and process drivers and passengers data. So this is also another challenge. Privacy by design is also a topic that Kate has mentioned. We have made something different, actually, and we are like developing that concept. You won't find it in the guidelines, but fairness by design is something that we believe should be more strongly highlighted in this kind of projects. Well, this was just a quick comment, and there are many other topics and things that could be said on this on this project, but well, I'm sure we will organize a new webinar soon to update also on the findings that we will present in the upcoming months. Thank you all, and Francesco, I'll give the microphone back to you.
Thank you, Vito. Okay, so right now we concluded our path analyzing the NIOV project, and so I'd like to move on the PREVENT project. So I'd like to move from a perspective in which the vehicles has to be protected in order to guarantee freedom and rights for data subjects, but safety for the users, in a field where safety is the main topic, the PREVENT project. So I leave the floor to Marco Capparelli that will illustrate to us the PREVENT project. Thank you.
Hello, Francesco, and thank you. I am Marco Emanuele Carpenelli, and I'll talk about PREVENT project. And just a minute, I'll share the screen. Okay. Okay, I am a fellow of the Italian Institute for Privacy and Data Valorization, IIP. We are the GDPR advisor of the PREVENT project. In this webinar, I'll show you the PREVENT project general goals and objectives. Then we'll move to the privacy by design methodology we have adopted in the context of the PREVENT project, and then the conclusion, the main red flags we have identified. PREVENT project. So the name PREVENT stands for procurements of innovative advanced systems to support security in public transport. Well, PREVENT focuses on preempting attacks in public transport by enabling earlier detection of terrorists and potentially dangerous objects, tracking of detected individuals or situations, and coordinating the response of security forces. This focus is shared from the start by 22 organizations from 10 countries, public transport operators, security forces, public buyers, city authorities, of which 12 are consortium partners and 10 are members of the PREVENT User Observatory Group, what we call UOG members. PREVENT implements a progressive and iterative process to deliver 6 jointly defined common security scenarios that capture threats and vulnerabilities. It also delivers a vulnerabilities and threats taxonomy directly applicable to the public transport world. For these scenarios, PREVENT undertakes a gap analysis between available solutions, existing standards, ongoing research, and identified needs, from which it elaborates a multidimensional roadmap of innovation and solutions. The roadmap is an online interactive tool that fits the sustainability of PREVENT's community. The highest priority innovations in the roadmap are selected by practitioners and public buyers to define a common challenge. This common challenge serves as the basis for a PCP, a pre-commercial procurement, for which the buyers group is created. The lead buyers is selected, tender documents are generated. Pre-bid includes also a governance mechanism that ensures that the different phases are open to additional practitioner and public buyers. And of course, Prevent includes also a security advisory board to manage the confidentiality of the sensitive knowledge and a GDPR advisor, so the Italian Institute for Privacy and Data Valorization. Well, the Prevent project privacy by design methodology, according to Article 25 of GDPR, this is our methodology. Our methodology approach was aimed to identify, by submitting questionnaires to public buyers from 4 different countries, France, Spain, Greece, and Poland, a list of regulatory references and recommendations to ensure the highest compliance with current data protection legislation. Not the most favorable, not the most friendly standard of data protection, but the highest level of compliance. The most restrictive level of protection within the territory of the member countries of the public buyers, what we call maximum common divisor. The maximum common divisor does not exclude, however, that in some national framework, there may be a less stringent and restrictive level of protection that may be still relevant and useful within the territorial context of the specific member state, what we call other smaller and not common divisors. So the adopted methodological approach was aimed to identify a list of regulatory references and recommendations to ensure the highest compliance with the current data protection legislation within the Prevent project. So with a focus on the national framework of Spain, France, Greece, and Poland. As I said, in order to define the list, questionnaires were submitted to public buyers. Through the identification of these relevant legal obstacles, we identified the most restricted level of protection. In the light of the outcomes of our report, of our work,
Marco, maybe we lost you for a bit. I don't know if you still are connected. Marco? Okay, maybe we lost Marco Capparelli, but in Italy we have right now more problems than internet connection, and so I don't know if it's gonna be connected.
Francesco?
Okay, Marco.
Francesco, do you hear? Okay, here I am.
Okay, yes, you're back. You can continue, thank you.
Okay, I'm sorry. I was talking about the main red flags we have identified in the context of the Prevent project in the light of the outcomes of our report. I have said that there would not seem to be absolute limitation or serious impediments on data protection.
Okay, we lost you again. So maybe you have some issues in the internet connection. So we'll wait just 30 seconds in order to understand if it's possible for him to connect again. Just 1 second. I just want to introduce the last, while waiting for Marco Capparelli, I would like to introduce the last part of this webinar, which will be very, very practical, which will be question and answer. I would like to invite two of the participants that I have with us today in order to brainstorm about the attack scenarios that can be performed while if security measures, technical ones and organizational ones, are not implemented. With us today, we have two penetration tester, chief cybersecurity advisor and cybersecurity advisor of ICT Legal Consulting, collaborators of Italian Institute for Privacy, which are Giuseppe Pro and Antonio Caragliano, that are with us in order to address the attack scenarios. So let's wait just 30 seconds in order to understand if Marco Capparelli can conclude. But if it's not possible, I'd start with the last session. I don't see him connected anymore. Okay. So we definitely lost him. So I would like to start talking about a standard, a guideline that synthesizes every single aspects that we addressed earlier, and that the project ngiot and the project Prevent addressed so far. The standard is the EHC cybersecurity in IoT for consumers standard, which contains several best practices, several cybersecurity best practices in order to achieve the goal of protecting, from a cybersecurity perspective, the IoT. So even the IOV, so even the objects that can be useful in order to prevent crimes or in order to check the transport field. First of all, the main topic is the password. NIST right now has changed its minds about the length of the password, but with a default universal password, an IoT product will be very vulnerable. What attack an attacker can perform with a universal default password? For that, I leave the floor to Antonio Caragliano.
I hope an attacker could do a dictionary attack on that password and that gain the access to the system. This is very simple attack because dictionary, you can find dictionary in the web very simply.
Okay, what about the fact that a default universal password can be listed in I don't think the dark web would be the proper answer to that, but even in the dark web, do you know if there are lists of default password of IoT products? Is this a reason for the IoT to be so vulnerable? I mean, we seen the case of the Google camera that was attacked just because the password was not changed by his owner. But does a list of default password exist on the web or in the dark web?
There isn't just a single list, but you can find more lists about several products. You can find lists of default password for routers and more products. So you can find the default password to IoT products too. Okay, so a simple but very effective security measure will be the password changing, even in the IOV, even in the crime prevention field, because every single piece of infrastructure of the crime prevention
I mean cameras, I mean biometrics or facial recognition cameras, could be hacked just through a universal default password that someone can steal from the web. Okay. Another important stuff, and I don't know if Giuseppe Pro is with us right now.
Yeah, morning to everyone.
Okay.
Thanks, Francesco.
Another thing, and I would like to leave the floor to him, it's the vulnerability assessment and penetration testing of the softwares that are connected and of the software that are developed in order to function on the IoT. And the vulnerabilities, the producer has to implement means to manage reports of vulnerabilities. In order to do that, we have to perform vulnerability assessment and penetration testing. Can you talk to us about that?
Sure. Thank you, Francesco. Cybersecurity start from the beginning. What allows vulnerability assessment or even a penetration test? Well, a vulnerability assessment consents us to know more about the vulnerability that affect our system, our devices. Every product that we use every day, from our smartphone, our connected cars, and even a lot of devices that are connected with ubiquitous device, our IoT devices. So a vulnerability assessment consents us to find the remediation for all our vulnerabilities, for all our weaknesses. So that's all in a simple way.
Okay, I mean, when you find vulnerabilities and you report vulnerabilities, you can give to the producer the possibility to fix those vulnerabilities. So when the producer fixes the vulnerabilities, and I want to arrive to the third point of the guidelines, when the producer fixes the vulnerabilities, everyone, the driver of an IOV, the owner or the sysadmin of a system of crime prevention has to update the system in order to fix these vulnerabilities. Everyone maybe in the audience have heard about WannaCry, but WannaCry was a ransomware that affected most of all UK countries, but WannaCry was exploited a vulnerability that was known, and a fix, a patch existed before in order to avoid the possibility for an attacker to install a ransomware in the system. So updating the system in order to guarantee data protection and security and even safety in the IoV field is fundamental. And so I would like to go on. I would like to go on and talking about cryptography, because we can defend ourselves, we can defend our vehicles, we can defend our cameras and our crime prevention systems with updates without using and storing properly the credentials, but there are attacks that are based on the absence of cryptography. First of all, there's the possibility to have the device stolen, but this is a problem that affects not only the IoT, but even our smartphones and our laptops. Second of all is the man in the middle. I would like Antonio Caragliano and Giuseppe, I mean, it's just choose who wants to talk about man in the middle attack. It's very important to address properly this issue, in order to understand why cryptography is important in this field. Giuseppe?
Yeah, okay, Francesco. What is a man-in-the-middle attack? A man-in-the-middle attack is an attack that is performed by an attacker that is present between the connection of two or more different users or devices. What are the main weaknesses of a man-in-the-middle attack? So the main problems are that our connection could be not encrypted. So this communication are available to the attackers. Our information could be used to perform other various different attacks. So encryption permits us to find the solution to a man-in-the-middle attack that give a patch to solve this problem. I don't know if my colleague Antonio Caragliano wants to add something. Please, Antonio.
No, I think that's all about the man-in-the-middle attacks.
Yes, but still, how to avoid it? We can avoid it only with cryptography. Right now, I know that the audience is very heterogeneous right now because not everyone can understand about cybersecurity and data protection. And I want to conclude with a brief explanation of why cryptography is so important, and it's a security measure that is related to GDPR. Why? Because GDPR has a risk-based approach. So whenever we address what kind of technical security measure we have to implement in a vehicle or even in a system of crime prevention, we have to address properly the risks about man in the middle too, as our colleague Giuseppe Pro just explained. Cryptography is a measure that Article 32 of GDPR actually states as one of the security measures that are needed. It's not because the legislator likes cryptography more than other security measures, but it's because cryptography has there is no flexible or easy way to change a security measure that comes with cryptography with another security measure. The only one that comes close to it is the possibility to substitute the cryptography at rest, the one that you can activate in your laptop with BitLocker or FileVault, or the one that some Apple products has on it, built in, with air gapping, which is a way of taking servers or storages away from the possibility to be stolen. But in the man-in-the-middle case, there is no way in order to prevent a man-in-the-middle in the framework of data communication. So when an IoT product communicate, or an IOV product or a camera communicate with the central system which stores the data, this connection has to be protected in order to avoid the risk we already talked about. And there's no other way in order to prevent it. There's no other way to substitute the security measure, these security measures with another one. That is why GDPR has a risk-based approach, but states clearly that you have to address the possibility to use cryptography. And you have to justify it if you don't want to use cryptography, because your risk is so low, and it's not the case of IOV, it's not the case of crime prevention, because the risk is so low in order to decide to avoid to use the cryptography. Right now, this is the most important technical security measure that connects our three projects. Because IoT will be in 5 years, in 3 or 5 years, everywhere, and will be connected and will be process personal data, even without us knowing it. And the possibility that an attacker, as Giuseppe Pro and Antonio Caragliano already said, can listen to our, not conversation, but to our transmission of personal data, it's very likely. That is why cryptography is so important, and that is why cryptography has to be considered as the main security measure, technical security measure to implement while designing and projecting an IOV, so a connected vehicle, or a crime prevention system that is connected to the internet. I would like to conclude thanking you all. And thanking you, Pasquale Annicchino, because he hosted us today, even if he's very busy, and we know, and we thank him for that. And I would like to thank Kate Francis, Vito Pavese, Marco Carpenelli, Antonio Caragliano, and Giuseppe Pro to participate to this webinar. And if you have any question, or we are free to answer to you right now. But if you have no questions, I thank you once again, and we can conclude. Thank you very much.